Hello everyone, welcome. So consider case of a video streaming platform Getflix. Okay. Now this video streaming platform has this particular kind of UI where it has mentioned various genres and based on what genre you select. So if you see here currently action and thriller genre has been selected. Okay. So based on what genre you select, it returns the trending movies in that particular genre. Okay, so say if a user wants to see what movies are trending in action and thriller genre, what happens is that this query runs in background. Okay, this is how it selects trending movies in genre. The views to that particular movie should be greater than 1 million, rating should be greater than 4.1, genre is action or thriller based on what has been selected here, and release year should be uh, more than 2023, so it will give latest trending movies. Okay, that is year should be 2024. Okay, so whenever a user wants trending movies in genre, this particular query runs in background. Okay, now let's consider a case where u1 comes and u1 requests movies that are trending in action or thriller. So what will happen? User has requested this particular thing. Now this Getflix application server, it will do computation, it will run this particular query in its database. It is a database server. Okay, not application server, this is a database server. In this database server, it will run this particular query to get the list of movies that are trending in action and thriller genre. Once it has computed, it will return back the result. Okay, it has returned back result R1. Now user 2 comes, it requests movies trending in romance genre. Okay, so this query will run. Instead of action and thriller, it will replace it by romance, and all the computation will happen, and user 2 will get its requested result back. Okay, it gets R2. Now let's say user u3 comes. Okay, user u3 has come, it again requests action and thriller genre. Now what will happen? This result has not been stored anywhere. Okay, so again this request, this is similar request, this request has already been computed by the app database server, but because the result was not stored anywhere, this computation will have to be done again. So again the request goes to server, it computes the result and it returns result R1. Same result is it has computed, but computation was done twice. Again let's say user u4 comes, it requests movies trending in romance genre, and because the result was not stored anywhere, this particular query result will have to be computed again. So if this Getflix becomes very famous one day, and let's say it has got 1 million active daily active users. Okay, and if these daily active users keep on requesting similar kind of queries, but this database server does not store the result of these queries, then it will have to do repetitive computation again and again. Okay, it has computed some results, but because it is not storing, it will have to do it again and again. It wastes the computational resources, it wastes CPU cycles of this particular server. Also, because there is request, computation and reply, so this request and reply also adds latency. Okay, so these are the two problems here. You are wasting the CPU cycles by computing same thing again and again. So how can this problem be solved? This problem can be solved using something called as caching. We'll see what caching is. Okay. So what happens in caching is, let's say there is a user u1 and it has requested movies in action or thriller genre. Action or thriller genre. Okay. So the flow of request would be like this. The request first goes to cache. Okay. It checks if this particular result is already present in cache. It is not present in cache, so it would go to the database server. Database server will compute the query query result, and it will return back the result. Okay. Now this result would be stored in cache. So it will store result of action and thriller movies. Okay. Now user u2 comes. It requests movies trending in romance genre. Again the request goes to cache. It checks if the result is already present in cache. The result is currently not present in cache. It would go to the database server, compute the result, and return the thing back to the cache. Okay. So it will store the movies trending in romance genre. Now, when user u3 comes and asks for action and thriller movies again, it will go to cache, and guess what? The result is present in cache. So this particular computation that was being done over and over again, this particular computation, all this need not be done now. The cache can simply return back this particular result to the user. This part of computation will not be done. This is how it saves computational resources as well as the latency we were seeing in the previous scenario. Okay. Now remember that cache is a temporary storage. Okay, it is not a persistent storage. The results that are present in cache would vanish after some time. So cache is a temporary memory which is used to store the queries that are frequent. If a query is not frequent, then there is no point in storing the result in the cache. Okay. And the queries which are computation heavy, that is, it takes quite a while to compute result of the query. So cache is a temporary memory that is used to store result of frequent requests that are compute heavy, so that the subsequent request would get the result directly from the cache. There are certain things you need to consider when you are using a cache. Okay. First thing is that cache is supposed to be used on systems that are read heavy. What is meant by read heavy? The number of read operations is more than write operations. Okay. What will happen if you use cache in systems that is write heavy? The data that is present in cache is modified again and again in persistent memory. So the cache will have to bring in the data again and again from the persistent memory into it. So in this particular system, the persistent memory is being accessed again and again. So there is no point of having cache. Even if you read or write persistent memory again and again, then there is no point of having cache in the system. That is why cache is supposed to be used on systems where number of read operations are more. That is, once you have written the data, you have a lot of read operations. Okay. Next thing is that cache is not to be used as persistent storage. It is not a persistent storage. Okay. So anything that is to be stored permanently is not stored in cache. Okay. Cache is a volatile memory. Whatever is present in cache right now, it might not be present after some particular time. Okay. So cache is not to be used for persistent storage. So something that is to be stored permanently, we don't use cache for that. Third is the data replacement policy. We'll discuss this in detail. Okay. Consider sequence of queries these are the sequence of queries and initially the cache is empty. ठीक है, query q1 comes to the cache is empty, so query q1 will go to the database server, fetch the result, and the cache will store result of query q1. Cache has got only 3 slots. Similarly, query q2 comes, it checks the cache, result for q2 is not present in cache, it will go to the database and fetch the result for q2. Similarly, q3 comes, it is not present in cache, so q3's result would be fetched from the database and it would be stored in cache. Now when q1 comes back, it sees that the result is already present in cache, so it will the result of query q1 would be returned directly from the cache. Now when q4 comes, it sees that the result of q4 is not present in cache, so the request would go to the server. Server will compute the result for q4, it will return back result for q4, result for query q4, it will return back. Now cache has to decide, since the cache is full, it will have to take out some result, so it has to decide what slot it will empty. It has got 3 slots, which slot should it let out. Now it is an important decision because it may happen that something that you are taking out, it may be requested in future as well. So there are certain policies, and based on your use case, these policies should be decided. So one policy is first in first out policy. What does first in first out policy say? Whatever data has come into the cache first, it will go out first. So out of q1, q2, q3, q1 came first, so first in first out will kick out q1 from the cache and it will store q4 in its place. Okay, so first in first out will kick out q1. There is another policy known as least recently used policy. So out of q1, q2, q3, which result was least recently used? So if you go back from this particular point, q1 was most recently used, then q3, then q2. These three are present in cache right now, and out of these three, q2 was the least recently used, so it will kick out q2. It will kick out q2 and place the result of q4 in place of q2. Similarly, there is policy known as most recently used. Most recently used policy. It will kick out q1 again because q1 was the most recently used. So depending upon what kind of application you are using it for, you will use what policy, what data replacement policy you will be using for replacing data from the cache. Okay? There is something called as expiration policy. Now what is expiration policy? You saw that in data replacement policies, this particular slot is not getting emptied. So it may happen that certain slot is not being emptied from the cache for very long time. In these particular cases, cache decides timestamp t after which it will empty that particular slot. Okay? Now what should be the value of t? It is very important. If t is very large, let's say, if t is very large, then this particular thing would not go out of cache for very long time. So in this case, cache is remaining filled for a very long time, but there is no use of it being in cache. So in this case, cache starts acting like persistent storage. Whatever is present in cache is present in cache for a very long time. It should not be present in cache for a very long time. If it is not being accessed by anything, then it should expire on its own after some particular time t. and t should not be very large. On the other hand, if t is very small, then what will happen? If t is very small, then data will come in and go out of cache very frequently. So let's say Q3 is stored in cache and t is very small. So as soon as Q3 came in, it went out as well. Now if application wants to access the result of Q3, it will come to the cache. It will see, oh, the result is not present in cache. It will go back to the database server. So in this particular case, system is acting as if cache is not present. So this is not useful as well. So value of t should be some intermediate value for which there is some use of having cache in the system. Okay? This value of t is again based on what application you are using it for. So you have to use t or set t wisely. Fifth thing is consistency. Now let's say Q3 is already present in cache and application has done some computation and Q3 is updated. Now this updated Q3 has to be stored back. Where should this Q3 be stored? Should it be updated in the cache or should it be updated in the persistent storage? If it is updated in cache, who will write the data back to persistent storage? If it is present in persistent storage or if it is updated in persistent storage, then the Q3 present in cache is stale actually, it is not updated. So how should we solve this problem? In order to solve this problem, we have write back mechanisms, write mechanisms for cache. We will see those mechanisms now. So first mechanism is write through mechanism. So whenever any data entry has to be updated, it will be updated in cache as well as in the database as well. Okay, so it is the application's responsibility. It is the application's responsibility to update it in both the places in write through cache. Okay, it is very simple policy. You simply update it in both the places. So next is write back policy. Okay, so in write back policy, the application will only update data into the cache. Okay, so let's say data d1, d2, d3 is present in cache. Now application has done some computation and has updated d1 to d1 dash. Okay, now it will update this particular d1 dash only in cache. Now when d1 is being updated in cache, this particular slot is marked as dirty. Okay, now let's say application requested for data d4 and d4 is not present in cache, and as a result of data replacement policy, this d4 is to be written in this particular slot. Now when this particular slot is to be emptied, before bringing out d1 dash and bringing in d4, it will write d1 dash onto the server. Why will it write? Because this particular slot has been marked as dirty. So only dirty slots will be written back into the database. So once it has written back into the database, this slot can be emptied and d4 can be brought into this particular slot. This will be brought back from database only. Okay, this is the write back policy. Now where should these caching mechanisms be used? So whenever you find that one part of the system is asking for information or requesting information from another part of the system, in between you can place cache. Okay, so very first example would be client caching. What is client caching? You might have observed that whenever you access some kind of websites, your browser asks for cookie storage information. So that cookies are being stored on your browser, right? So this is what is known as client side caching. the browser is on present on client side, and it stores the data for website, that is client side caching. Now, if you have seen my proxy video, you might have seen that in front of the application server, there is a reverse proxy server. There is a reverse proxy server, and whatever requests response are coming back from the application server, the reverse proxy server them, stores them as a response. So what it is doing, it is actually caching the responses coming from the application server. This is known as server side caching. The example that we saw in this particular case, in case of Getflix, we are storing the response of the database, right? So in this particular case, it is database caching. Fourth is DNS caching. So DNS actually gives the mapping of IP address to the domain name. Now DNS also uses some cache, so it does not go and find a particular IP address and its corresponding domain name every time. Frequently used domain names it caches onto itself, so it need not find those IP address again and again. So that is known as DNS caching. In this series, we have also seen content delivery networks. So what are content delivery networks? Content delivery networks are used to store static content of website. So this static content of website is actually cached on content delivery networks. So it is known as CDN caching. And last is application caching. What is application caching? So an app is running on a particular server, and that app can use the cache of that particular server to store the responses. This is known as application caching. I hope you would have understood this. Thank you.